Welcome to this explainer. Today, we're literally peeling back the walls of a modern high-rise to look at the invisible engines that power our cities. We interact with these systems every single day, right? But we rarely stop to think about the massive global industry that builds, maintains, and ultimately manages the risks associated with them.
You might think it's just steel and glass. The architectural marvels that catch our eye from the street. But I want you to ask yourself, what really powers the modern skyline? What breathes life into these static structures and actually makes them habitable, comfortable, and safe for millions of people?
Well, it's the non-structural building components. If we take a split-screen view of modern residential and commercial high-rises and just zoom right past the drywall, you find the vital organs hard at work. We're talking smart HVAC units humming along to maintain the perfect climate, high-speed elevator shafts in synchronous motion, automated security devices scanning for anomalies, and advanced LED lighting fixtures automatically adjusting to the daylight outside. These climate control and building systems are absolutely crucial. They are what transform an empty shell into a living, functional ecosystem.
Now, to understand the sustainability risks and opportunities of the companies manufacturing these massive, complex systems, investors and analysts don't just guess, they use a very precise blueprint. It's the SASB accounting standard for electrical and electronic equipment, commonly known as the REE standard. This framework provides a highly standardized way to measure everything, from the sheer energy these systems consume, all the way down to the ethical practices of the companies building them around the world.
Think of our agenda today as a sort of building directory. We're going to explore inside the smart building, look at energy and life cycle management, dive into product safety and recalls, uncover hidden impacts like waste and sourcing, and finally examine the business ethics foundation. Let's jump in.
Section 1. Inside the smart building, where we measure the scale of the industry.
So the standard tracks the industry's massive footprint using a specific activity metric, RTEOOO.A, and it works by counting the sheer number of units produced across some major categories: energy generation equipment, energy delivery systems, and, crucial to our smart building concept, lighting and indoor climate control electronics. When you break down the numbers, an enormous percentage of this global industry's revenue is derived directly from manufacturing these everyday components.
Moving on to Section 2, Energy and Lifecycle Management, tracking the green systems.
There's a really important distinction the standard makes here between a minor design tweak and a true eligible energy efficiency product. For instance, if a manufacturer just makes a conventional product slightly lighter, the standard says, okay, that's an ancillary indirect improvement. It doesn't actually count. But building smart grid technologies, demand response systems, or low-loss transformers, those demonstrate a meaningful increase in energy efficiency during the product's actual use phase that directly drives future market share and gets tracked as dedicated revenue.
A key driver of that growth is the smart grid. The framework specifically defines this as a complete modernization of our electricity delivery systems. Basically, it's the critical optimization link between those central power generation plants miles away and the very building automation systems we rely on every single day to keep our lights on and our air conditioning running efficiently.
But here's the catch. Building these incredible green technologies requires massive amounts of power in the manufacturing phase. So, the standard demands absolute transparency on the manufacturer's own energy footprint. Under metric RTE 130A.1, companies have to disclose their total energy consumed in gigajoules. Furthermore, they need to break down exactly what percentage comes from traditional grid electricity versus what percentage comes from renewable energy sources, like wind, solar, or hydro.
Section 3. Product Safety and Recalls. Bringing in the human element.
Because these companies build things that directly impact our physical safety. Think about high-speed elevators, complex security devices, massive electrical panels. A critical metric to track is RTE 250A.1. This measures the total number of recalls issued and the total units recalled, and it encompasses everything, both voluntary recalls initiated by the company to fix a defect and involuntary recalls mandated by government regulators to protect us consumers from immediate safety risks like electrical fires.
The crucial point here is that a malfunction in a smart building isn't just a minor inconvenience. The framework specifically highlights what it calls notable recalls. A recall escalates to notable status when it affects a highly significant number of products, or, much more severely, when it's related to serious injuries or fatalities.
And this human risk directly translates to the bottom line.
Under metric RT E250A.2, companies are required to disclose their total monetary losses resulting from legal proceedings associated with product safety. We aren't just talking about a few refunds here. We're talking about major civil judgments, regulatory penalties, and even criminal judgments. Plus, they have to publicly detail the corrective actions they're taking. That might mean changing their manufacturing processes entirely, or overhauling their technology to ensure it literally never happens again.
Section 4. Hidden Impacts. Looking into the invisible supply chain.
Building these sophisticated electronics and HVAC units generates substantial hazardous waste. We're talking heavy metals and wastewater treatment sludge. This metric, RTEE150A.1, forces companies to show exactly how much hazardous waste they generate in metric tons, and more importantly, the percentage that's actually recycled. The standard is notably strict on this. Waste that is reused or reclaimed counts as recycled. But if you just incinerate the waste, even if you're doing it to recover energy, it absolutely does not count as recycled.
On the intake side, manufacturing these advanced climate and automation controls requires what the standard refers to as critical materials. These include rare earth elements, platinum group metals, cobalt, and tungsten. These materials are absolutely essential to the technology, but they're incredibly vulnerable to geopolitical supply restrictions because they're often sourced from just a handful of countries globally.
To avoid crippling supply disruptions or massive price spikes, companies have to detail their risk management strategies. How are they surviving this? They have to step through their exact mitigation plans. Are they diversifying their global suppliers? Are they physically stockpiling materials? Are they developing new substitute materials? Or maybe heavily investing in recycling technology so they can extract these critical elements from old electronics?
Finally, Section 5, the Business Ethics Foundation, governing the global operation. Because these manufacturers operate globally, they face intense regulatory scrutiny. They are highly vulnerable when operating in regions with weaker government enforcement. The standard requires full disclosure of any monetary losses stemming from two major ethical pitfalls. First, bribery and corruption, such as bribing foreign officials. And second, anti-competitive behavior. This includes actions like price fixing, patent misuse, exclusivity contracts, or unfairly bundling products just to limit competition. If a company's foundation is cracked by unethical practices, it jeopardizes their future revenue and destroys brand value.
So I want to leave you with this thought. The next time you step into a high-rise commercial building, or simply adjust the smart thermostat in your own home, look past those sleek lobby aesthetics. Ask yourself about the invisible engines all around you. Who built them? How much energy did it actually take? What critical materials were pulled from the earth to make them run? And what global risks are hidden right there within those walls? It's a fascinating, deeply complex ecosystem. And now, you know exactly how to measure it.